Let's use letter B. So this is equal, y is equal to 3 times 2x plus 1 raised to 3. Okay, we know what is dy over dx. It must be equal to what's that? 3 times, so just 3 times the derivative of 2x plus 1 raised to 3, which is times, how do you differentiate 2x plus 1 raised to 3? 3, 2x plus 1 raised to 2 times derivative of 2x plus 1, which is 2. So using the chain rule. Okay. And then 3 and 3 and 2 becomes 18, and you have 2x plus 1 raised to 2. And that's the final answer for the first derivative. Second derivative, d2y dx squared. So 18 times 2. You can also do it directly. So 18 times 2 becomes 36, right? You can get the 36 directly. And 2x plus 1 raised to 1, let's just write 1 times 2, which is equal to 72, and then 2x plus 1. Now, if we are supposed to simplify, we can distribute the 72 to 2x and 1. That means we have 144x plus 72. Or you can leave it as 72 times 2x plus 1. And then for the third derivative, so you can work on this. So this is equal to 144. And what do you notice if we continue? d4y dx4, 0, and d5y dx5. Derivative of 0 is 0. 0 is a constant. So the derivative is also 0. And as you can see, if you go on and on, there will come a time that the derivative becomes 0 for some functions. Other functions, they will remain as expressions, but some functions will eventually become 0 once you get to the higher order derivatives. Okay? So again, higher order derivatives can be applied to different functions. In our example, we can use it on the something that can be that we can use a chain rule. Okay, but sometimes there are examples in which they are given as polynomials. We just find the derivative the usual way. Okay, any questions? Clear? Okay.